Okay, so good afternoon, learners, or rather good day, because you can be viewing this in the morning, afternoon, or evening. So, my name is Mr. Excellent from Peasley Montessori School, the basic science tutor, and today we'll be looking at the topic work, energy, and power. Now, these are words we already use conventionally in our day-to-day activities. For instance, your dad can wake up in the morning, take his bath, drink his coffee, suit up and take his briefcase and say, I'm off to work. However, today I'll be explaining the concept of these words scientifically. So, let's begin. What is work? Now, from the slide here, work is said to be done when an applied force moves a body through a distance. I'm going to take that again and get the emphasis on the words I'm using. Work is said to be done when an applied force. So the first word you must take note of is that before work can be done, force must be applied. And it has to be applied to move a body through a distance. And then as we go on, you will see that some of the things you call work is not actually work. So some of the things you do, that you say, I'm doing work, you have done nothing according to science, right? Alright, so it's going to be an interesting journey. So again, work is said to be done when an applied force moves a body through a distance. Alright, so from the formula for work, mathematically, work equals force times distance. That is the product of force times distance. From your basic mathematics, you already know that work is multiplication, can also be said to be product. So we can simply say that work is the product of force and distance. Again, work is the product of force and distance. Now, we have a diagram here. The first picture, there's a young man trying with so much effort to push a rock. But from the thing here, you see that the rock is not moving. So even if the guy is dissipating energy, he has done no work. Why? He's applying force? Yes. Is the body moved to any particular distance? No. So, if I'm to take the work done there, the work done will be zero, because distance moved is zero. There is force, yes, because previously I've told you that work is what? Force times what? Distance. So, since there is force being applied, let's assume the force is 50 Newton, and the distance there is zero, since no distance has been moved, since no distance has been covered. So, my total work done will be 50 times what? Zero. That's the force 50 and the distance 0. So everything will what? Sum up to what? 0. So work done is 0. Now from the other diagram, the second place, another young man comes to help him, and both of them apply the force together and the rock moves. Immediately the rock moves, work has been what? Done. So for instance, if a learner stands up from morning till night, taking a chair, and he raises it up, as long as no distance has been covered, no work has been done by that learner. He may be using energy. Energy is different from work done. That is why even in life, you have to use energy, you have to channel energy to do the right things for you to get things done. You can have energy, you can use your energy to talk from morning till evening, and no work has been done. So it's not enough to have energy. You must what? Apply it for you to say work has been done by you. So, a learner can take a chair, raises it up from morning to evening, and no work has been done. Another one can decide to walk aimlessly. He's walking aimlessly, he's covering distance, but he has applied no force physically. No one is pushing the learner. So, he's walking, there's no force in it. So, work is only done when there is force. There's a body that is being moved, and there's what? A distance that is being covered. So, a learner taking a chair, raising it up, there's force, there's a body, but there's no distance. Work has not been done. A learner walking up and down the school without anything, there's distance covered, but there's no force to move that body of the learner. Is moving it. There's a perpendicular equivalence, having no force. Alright, so let's move on. So you may ask me, what is force? Force is that which changes a body's state of rest. Force is that which changes a body's state of rest. So for instance, we have several kinds of forces. We have the contact force and the force field. So if I have a stool here and I push this stool, that push is a force, is a contact force. I'm making contact with the stool to push it. It's changing it from a state of rest into motion. So force is that which changes a body state of rest. Alright, now what's the formula for force? Force is simply mass times acceleration. And then in this course, you are going to find out that we have acceleration due to gravity. Yes, so if you jump up, you are going to come down. There's going to be an acceleration due to gravity, which we approximate to be 10 meters per second. So, let me take it again, that force is that which changes a body's state of rest. Then the formula for force is mass times acceleration. That is, force is the product of mass and acceleration. Now quickly, let me go back here. So, from the formula I gave you for work, I said work is force times distance. And now force itself is mass times acceleration. If I am to substitute force, where force is in the formula of work, instead of force times distance, force is mass times acceleration, I will now have that work done is equals to mass times acceleration, which is force, times distance. Let me come again, don't get confused. Stay with me, stay with me. Now, I said work done is what? Force times distance. And force is mass times acceleration. So, work done is what? Mass times acceleration, which represents force times distance. Hence, work done is equals to MAD. Popularly called what? Mad. But with not mad, no one is running mad here. So it's just, this is an acronym for you to remember the what? Formula for work done. The work done equals to MAD. Mass, acceleration, and distance. Are you still with me? Now, what is energy? Because the topic is work, energy, and power. So energy is the capacity to do work. Is that inherent, inbuilt capacity to do work. So we have energy giving food. When you take in energy giving food, what it does is that it supplies your body with the capacity to do work. So you can have the capacity to do work, yet you have done no work. It's possible. Yes. So for instance, if I begin to dissipate energy in working aimlessly, as I've said before, no work is done. So I have the energy, I'm dissipating it, but doing no what? Doing no work. So let's move on. Then the last thing there is power. Now power is defined as the rate at which work is done. Power is defined as the rate in which work is done. So when you hear the word rate, it has to do with what? It has to do with time. So when we bring the concept of power, what we are trying to say is that we are trying to look at the particular time in which a work or in which a particular work is done. So, for instance, if I give two learners the same stool, having the same mass, that's the same weight, for instance, to push to a particular distance, the same distance, if one learner pushes it there before another, that means the other learner has greater power because he did it at a lesser time. So work, power rather, is the rate at which work is done. Now quickly, let's look at the formula for power. Power will be what? Work done times time over time taken. Power is work done over time taken. Power again is work done over time taken. Is a work that you've done divided by the time it took you to do that particular work. I believe you are still with me. Now let's quickly look at the units. The unit for mass is kilogram. The unit for force is Newton. The unit for work is joules. Again, the unit for mass is kilogram. The unit of force is Newton. And the unit of work is joules. Now, the unit for energy and work are the same. Energy is also joules. We are going to have this in a further class, in another class, where we will deal with potential and kinetic energy. But for now, let's focus on work done. Now, the unit for distance is meters. It's also the unit for height, because height can be given. They are all measured in meters. And the unit for power is watt. The unit for time is seconds. That means what we measure time in. What time is it? What time did he use in doing a particular job? We measure time in seconds. Also, another unit for time that you're already familiar with is the minute and the hour, the day, years. These are all units for mass. How old is he? Unit of time rather. How old is he? We measure age in years. It's a unit for time. I can also measure it in seconds. I can convert that to seconds. Then the unit for acceleration is meter per second square. Now, let's take examples. Let's take examples. So the first example we're given here is what work is done when a mass of 5.0 kilogram is raised through a vertical height of 2.5 meters. And then you are given a hint there, and the hint is that acceleration due to gravity is 10 meters per second. Now when you have questions like this, the first thing to do is to write down your parameters. What have I been given and what is expected of me? So let's take this question again. What work is done? So what you are asked of in this question is the what work done is done when a mass, so you can write it down, mass is given 5 kilogram. It's raised through a vertical height. Height is same thing as distance. Height is given. Distance is given. And acceleration is given as 10 meters per second square. Now, when you are to solve questions like this, what is expected of you is the work done. First, write the formula. So work done is equals to force times distance. But going back to the question, force is not given. However, mass is given and acceleration due to gravity is given. So, going back to the formula, since force is mass times acceleration, my work done will become mass times acceleration times distance. And my mass is 5 kilogram. So I substituted them where I see mass 5 kilogram. The acceleration due to gravity is 10 meters per second square, and the distance, which is the height, is 2.5 meters. Then when you make this, when you calculate this, you will get 125 joules. That is the unit of measuring work done. So again, work done is force times distance. Since force is not given, however, the mass and the acceleration is given. Now, let's take another example. A pumping machine raised 75 kilograms of water through a height of 5 meters. Let me take it again. Raises 75 kilograms of water. Now, kilogram is unit of what? Mass. So mass has been given. You write it down. Mass given. Of water through a height. Height represents the what? The distance. Distance is given as 5 meters. So, what is the work done by the machine? G equals to 10 meters per second square. Now recall that this G represents what? The acceleration due to gravity, since it's raising it through a height. Alright, so let's go. From the first write your formula, we're looking for the work done. So work done is force times distance, and force is mass times acceleration. Your acceleration is that G there. G is acceleration due to gravity. Hence, your force is the mass, which is 75, multiplied by your acceleration, which is 10. So your force will be 750 Newton. Remember, the unit of force is Newton. Alright, so your distance is given as 5 meters. So if I'm to substitute, my force is already given in this situation, 750 Newton. So my work done equals to 750 times the distance, which is 5. So everything is going to give me 3,750 joules. Now, the word kilo means 1,000. So to convert joules to kilojoules, I have to divide my joules by 1,000. Whenever you see the word kilo, the first thing that should come to your mind is what? 1,000. So 1,000 meters make a kilometer. 1,000 liters makes a kiloliter, which is also the same thing as a meter cube. Now, 1,000 gram makes a kilogram. So 1,000 joules make a kilojoules. Alright, quickly, next example as I intend to wrap up this session. Now, a boy pushes a box along a horizontal surface with a force of 15 Newton. Come back, stay with me. This case, the force is already given to you as 15 Newton. So please write it down. It says find the work done in moving the bags through a distance of 5 meters. Stay with me, please. In this case, the force is given. This case, the force is given. The force is 15 Newton. Find the work done in moving the bags through a distance of 5 meters. What else is given? Distance is given. So this question is very straightforward. Very straightforward question. Alright, so how do we go about it? First thing first, write your formula. Work done is force times distance. Why am I writing formula for work done? Because I'm asked to look for the work done. Alright. So, the work done is force times distance. Now, force is 15 Newton from the question. Distance is 5 meters. So, to calculate my work done is the product of force and distance. Multiply 15 by 5 to get me 75 joules. Alright. So, take home snack. This is your take home snack. You do that, and how I want this take home assignment done is that you type it out and send it to the class platform. And then you can email us your questions. As well, you can drop your questions in the comment section, or you can ask me those questions when we meet in the class. Alright, the first take home snack is given here as find the work done by man who lifts a weight of 20 Newton from the ground to a vertical height of 4 meters by means of a rope. Then the second one is calculate the work done by a body of weight 200 Newton which moves through a distance of 12 meters. It's been an interesting class. See you next time. Thanks for your time, and do have a lovely day ahead. Lovely night, as the case may be, whenever you are listening to this recording. Thank you very much. Till we meet in class. I remain Mr. Excellent from Business School.